Hi people, so we are the problem solving club and we are solving a physics problem today. So as you know, any physics problem is just observe a natural phenomenon, ask why, and that becomes a physical problem. So we have a guitar here, a standard guitar fretboard. You can see the picture. This on the left is called the neck of the guitar, and somewhere extended beyond that is the bridge of the guitar. And when you pluck a string, that's basically when you play guitar, when you pluck a string, your wire vibrates between the neck and the bridge and makes a sound. That's how it's played. These little metal divisions are called frets. There. These are called frets. And how you play the guitar is you press down your finger, say here, and that decreases the effective length of the vibrating part of the string, and that increases the frequency. That's how you manipulate the frequency and you play the guitar. The question here is, why does the gap between the frets become less and less as we move down the neck of the guitar? You see the gap here is, it's a certain amount, and as you move down the neck, it becomes closer and closer and closer. So yeah, that's the question. Okay, so the trick to solving any physics problem is, just a basic approach, is break down the problem in little parts first. So we'll look at a certain string, first string, second string, whatever floats your boat. Look at a certain string. That's the neck. That's the bridge. And the strings, when plugged, vibrates between these two ends. And we'll call a certain fret, say here, we'll call this fret the nth fret, and we'll call this distance xn, while the whole string is of length capital L. And we'll say, okay, this, while we pluck this effective length of the string, this makes a frequency of nu n. And therefore, when the open string is plugged, we have nu naught. The first string is plugged, we have nu 1. The second fret is plugged, we have got nu 2, and so on. Now we'll investigate what conditions are there on xn, x1, x2, x3 to produce musical sounds. Now here's something about music, is that a tune has to have translation and invariance along the root notes. That is, if you play a tune, and if you play that tune 2 notes higher, it needs to sound the same. Only there needs to be a constant frequency gap between those two tunes. What that means is that the relative relation between two consecutive frequencies needs to be the same, and the only relation between frequencies is the ratios. So here's something we know about something very fundamental we know about the guitar, is that the relative ratios of consecutive frequencies remains same. So nu 1 by nu naught equals, that ratio equals nu 2 by nu 1 equals nu 3 by nu 2, and so on, and nu 12 by nu 11. Now why 12 is important? Because 12th fret happens to be the fret right in the middle, and if someone has played a guitar ever, they'll know that when you pluck the string, keeping your finger right in the middle, you have exactly twice the frequency as that of the open string. So here's something we know from beforehand, that nu 12 happens to be exactly twice of nu naught. And if we call this ratio a certain number eta, that's characteristic of the instrument, then we have this relation, nu n equals nu naught times eta to the n. That's pretty clear. If you do some substitutions, you'll get it. Okay, now we have this. The velocity of the standing wave in this guitar is a function of the tension in the string and the mass per unit length, root over T by mu. And that's a constant for any of the frets. So lambda n, that's wavelength of the nth fret standing wave, times nu n is our velocity, which happens to be a constant, and xn, that's this distance, is just half of the wavelength of that standing wave, because standing wave goes all around like that. So xn nu n is just a constant that happens to be twice of velocity, but that's not important. What's important is that these two numbers multiply to give me a constant, which means xn nu n equals x naught nu naught. But we know x naught, that's the length of the vibrating part of the open string, is just the whole length of the string, and nu naught is the frequency of the open string. So I have got xn equals L times nu naught by nu n. But then from this relation out here, I know that nu n is nu naught times eta to the power n. So I've got xn equals L times eta to the power minus n. Also I know something. I know that also nu 12 happens to be exactly twice of nu naught. So this gives me the value of, oh yeah, and this is also equal to eta to the 12, because it's the 12th fret times nu naught. This gives me the value of eta 2 to the 1 by 12. This constant is an extremely constant in music, because this happens to be not just in guitar, this happens to be throughout music. This happens to be the ratio between the consecutive any two notes. Now we use this relation, xn equals L times eta to the minus n, which gives me xn equals to L times minus n by 12. Now our job is almost done. Erase this a little. Now we just need to find the difference between two consecutive frets. I will define the fret difference nth as modulus of the n plus 1th fret distance minus the nth fret distance, and that comes out to be, due to a little math, 2 to the minus n plus 1 by 12 minus L times 2 to the minus n by 12, and that gives me L times 1 minus eta to the minus 1 times eta to the minus n. Now all of these being a constant. Now see, eta is a number greater than 1. 2 to the minus 1 by 12 is a number greater than 1. And we have a final expression, some constant times eta to the minus n. This now makes clear that the fret gap falls. It not only falls, see, as n increases, the fret gap decreases. That's clear, because it's a minus n to the exponent. And it not only falls exponentially. So that's it. An important and extremely interesting interpretation of this this result is that when you have got an instrument like a violin that does not have frets, say that's sort of a violin, it's a very bad violin, that does not have frets, as you move down the neck, you're playing very high notes, your consecutive notes become closer and closer, and for a beginner violinist it becomes very difficult to hit the correct note when they are high up. So that needs a lot of practice, because you don't have frets in a violin to guide you. So that's something that the guitarists have going easy for them. That's it. Thank you.